Hello everybody and welcome back to the MMO project where we're still working on our map generation here and we're going to keep doing that for quite a while. Let me just throw that out there. This is going to be maybe a bit long of an episode. We'll see how long it actually takes to re-implement this. But the first thing I want to do is I want to go into our representation and create a new C# script in our scripts folder, and we'll call this map region. Excellent. We're going to need a data class here to contain a fair number of things. We're going to be needing system.collections.generic as well as systems. We do not need this to be a mono behavior, and we are simply going to remove everything in here. We're going to need two fields, so let's go ahead and make a region, and we'll call this public fields, and we'll make another region. Wonderful. And then we will go ahead and say public bool flooded equals false. We're not going to use this episode, because there are issues. We're going to need to iron those out. That'll be next episode. But we are going to do public int height equals 0. Wonderful. And this needs to, of course, be end region. There we go. And then we need to get ourselves a property here because we want to be able to use an operator. So let's do public tuple. We're going to be doing an int tuple again. And then we're going to do this int key in square brackets. Excellent. And then we'll get and we'll return tiles key, which doesn't exist yet. We'll implement that in just a moment. And we'll also do set, and this will be tiles key is equal to value. Excellent. Now, of course, that doesn't exist yet. So let's make ourselves a list here. So that'll be a list of tuple int, and we'll call that tiles equals a new list of tuple int. And then we'll do a hash set as well of tuple int, and we'll call that hash tiles with a capital T. Hash tiles equals new hash set tuple int. Wonderful. And now we're just going to implement a couple of little helper functions for us here, and these are largely going to be wrappers around the list class that allow us to just extend that a wee little bit here. So we're going to do a public void add tile, and that takes in a tuple int tile. Excellent, and that's just a coordinate, right? So that's not too hard. So then we'll do tiles.add, and then we'll add tile. We'll also add it to our hash set. So hash tiles.add tile. Excellent. And the reason that we're doing this is like we did in the pathfinding for speed, because we're going to need to very quickly know if the region contains a particular coordinate or not. So we're going to then do an add range, public void add range, and then we're going to pass in a list of tuple int range. Excellent. And then we'll do tiles. There we go. Add range. And then we'll simply pass in the range. Now there is not an add range function for the hash tile, or for the hash set, which I'm sad about, but we'll just simply do for int I equals 0, I is less than range dot count, I plus plus. We are going to do hash tiles dot add range I. Excellent. Now a couple more functions that we'll do here. We'll do a public bool contains, and this will take in a tuple int tile. Excellent. And then we'll simply return hash tiles.contains tile. And that's the reason we're using the hash set here. We'll create another helper function for us so we don't have to type out creating the new tuple every time. We'll do public bool contains, and that'll take an int x and int y. All that'll do is return contains new tuple int xy. But this way we don't have to type out tuple every time. And then we'll also do public void remove tile, and that will be tuple int tile. And then we'll do tiles.remove tile, as well as hash tiles.remove tile. Excellent. So that's all we'll have for our map region for now. I'm sure we're going to be doing more with this a little bit later on. But let's hop over to our tile set, because we're going to need to do a little bit here. And in the tile set, I want to put in a quick extension to lists here. I'm doing it here because we're going to be using it from the tile set lists, so that's the reason why I'm doing this here. We'll just do a public static class list extensions, and then we will simply do a public static t get random item of type t, and then we'll pass in this list t list, as well as system.random. We're going to pass in a random number generator. Excellent. And then we'll simply return list random.next between 0 and list.count. Excellent. So that'll just return a random item of type t in the generic list, and we can access that from the list itself since it's an extension function. Wonderful. Now we're going to need a couple more lists in our actual tile set. Let's give ourselves a public tile, and we'll call this a water tile with a capital T. There we go. And then we'll add in two more lists here. Public list tile. This will be cliff corner inside tiles equals a new list of type tile. We're going to need another one. Public list tile. We'll go with cliff. That's a capital I. There we go. We'll go with cliff corner outside tiles equals a new list of type tile. We'll do the same thing for shores. We're going to need shore corners as well. So public list tile. This will be shore corner inside tiles equals new list of type tile. And we'll also do a public list tile shore corner outside tiles equals another new list of type tile. Excellent. So that's everything we should need in the tile set for right now. And then let's pop over to tile, where we're going to put in a couple of enums here. We're going to need a public enum tile type, and that's going to be flat, water, shore, cliff for right now. I'm sure we'll extend that later. And we'll also do a public enum line direction here, which we're mostly going to use for determining what type of shape the cliff or the shoreline is. And that can be straight, it can be corner inside, and it can be corner outside. And technically there are a few more it can be. For example, it could also be island, and it could be something like a skinny peninsula sort of thing. So we'll call that peninsula. Now we're not going to utilize island or peninsula just yet. Those are not going to be supported currently. Okay, so in the actual tile class, we don't need to do anything at all. We just needed these enums. Wonderful. And everything else that we're going to be doing is going to be in the map. So that's going to be exciting. Well, not strictly speaking everything, because we need to work with our tile sets a little bit here. Let's pop open Blender here, because we need to do a little bit of face work, because our face orientations are not exactly correct in our new tiles. So we'll just select all of these faces here, and we will flip these around. There we go, and then we'll flip that normal. There we go. And we'll check underneath. Yep, that looks good. Wonderful. We'll do the same thing over here. We'll flip these around. Just like this. Nope, not object name. I want to flip those normals. Excellent. We'll check underneath. Looks good. And we'll do the same thing over here. We'll flip all of these normals around, because Blender doesn't quite understand what we're trying to do here. And I don't blame it, it's kind of weird. Okay, excellent. There are those done. And we're going to Alt-H to get these faces back here. And we'll just select those and flip those around. Checking underneath looks good. Same thing here, Alt-H to unhide. And we'll flip these normals. Looks good underneath. And finally, Alt-H to unhide. And we will flip these normals around. Looks good. Okay, so there's our normal work done. Now we're going to need to make ourselves a few more tiles. We'll go ahead and bring the basic tile set out here, and we will unpack this prefab completely so that we can properly work with it. We're not going to need these. We're not going to need these shorelines. We're not going to need the ramps. We're not going to need the straight. I think we will need the water, though. Okay. So let's go into our prefabs here, into our prefabs in our tile set folder here. And we're going to want to make sure that this tile water here is in, and we'll call this tile_water. Wonderful. We'll go ahead and delete it here, and we will add in our components that we're going to need, which are the mesh collider. We're going to need the tile, and we'll want to make sure that we check... Oh, you know what? We forgot. This is the server here. I don't think there should be pathfinding on the server. I think that was open in error. Okay. As I was saying, the tile here actually needs to have a reference to its tile type. So we'll go ahead and place that right here. So we'll do a public tile type. And that'll be by default equal to tile type.flat. And of course, I typoed public because when don't I? I did it again. Okay, there we go. And we'll let that compile up. And now we can set this to type water. Fantastic. And now we'll go ahead and add in an input object. Okay, so there's our tile water complete for now. Let's go into our cliffs folder here, and let's create ourselves a new folder, and we'll call this straight. Excellent. And I kind of want to rename these, so we'll call this tile cliff straight 01. We'll call this one tile cliff straight 02. And we'll call this one tile cliff straight 03. We'll select all of them, and we'll make sure that they're set to tile type of cliff. Wonderful. And then we'll put them all in that folder, and we'll create a new folder. And we'll call that corner inside. And that means these guys here. We'll go ahead and move them out so that we know which ones we're working with, and we will add in our input object, we'll add in our mesh collider, and we will add in our tile script, and we will make sure to set tile type to cliff. That will be important. And we're going to have to just do this one at a time, sadly. So we'll put these in over here and make them into prefabs. Get rid of these. And we will name this tile cliff inside. Actually, we'll call this tile cliff corner inside underscore. There we go. 01. We'll call this tile cliff corner inside 02. And this one will be tile cliff corner inside 03. And then we'll just place all of these inside of this folder, but we'll also remember to assign it to the list here. So we don't have our water tile yet. We should definitely do that. So let's go into our prefabs and we'll put in our water tile. And we'll also go to our cliff corner inside folder, and we will put in our cliff corner inside tiles. Fantastic. Now we need to do the same thing, essentially, 3 more times. So now we're going to do the cliff corner outside. So we'll go ahead and add in our tile. That's fine. We'll set it to cliff. And we will add in our mesh collider and our input object. Excellent. We will make ourselves a new folder. This will be corner outside. Excellent. And we'll go ahead and put these in. And we'll delete these. Those are no longer necessary. And we'll call this tile, cliff, corner. Or did I just call it... I can't remember if I called it corner inside. I want to be consistent. I did call it corner inside. Okay. Tile, cliff, corner, outside, O2 for this one. And then this one should be tile, there we go. Cliff, corner, outside, O3. Wonderful. And we'll remember to add that to our tile set. Just like that. Wonderful. Okay, now we need to do the same thing for the shores. So let's hop into the shore folder here, and we'll go ahead and create a folder, and we'll call that straight. And we'll rename this to shore straight 01. Wait, shouldn't they be tile shore straight? Yes, they should. That is correct. Tile underscore shore straight. There we go. Now we'll do here tile shore straight 02. And tile shore straight 03. We'll place all those in. Wonderful. And then we'll do our folder, and we'll call this corner inside. And that should, of course, be these ones. Go ahead and separate them out like so. And we'll put on our input object, as well as our mesh collider. And our tile object. We'll make sure to set these to shore, and that reminds me, we did not set these to shore. We absolutely should. Those are now set to shore. Perfect. Okay, so these are set to shore, and so we should be ready to turn them into prefabs, and so we shall. And then we'll call this tile shore corner inside underscore 01. And we'll call this tile shore corner inside 02. And tile shore corner inside 03. Perfect. And we will now set them up in the tile set here. Like so. Corner inside. Perfect. One more to go. Almost done with this tile set work. This is very tedious work. There's no doubt about that. So we'll set these to shore, and we'll add in a mesh collider as well as an input object. There we go. And we are pretty much ready to make our folder here. This will be, of course, corner outside. Wonderful. And then we will go ahead and make this tile shore corner outside 01. Excellent. Tile shore corner outside 02. And finally, tile shore corner outside 03. And we can get rid of that. There we go. And let's remember to add it to the tile set object. So that is, of course, corner outside. Excellent. And that gives us all of our tile set bits that we need. Fantastic. So now we can pop back into the code and start actually sinking our teeth into some of this, which is good, because we are going to need to work very heavily in the map. So the first thing that we're going to do is, outside of these const fields, we are going to go ahead and put in a new public list here. Public list, this will be map region, the new class we just created. Regions equals new list map region. Excellent. Let's see, is there anything else we need here? Yes, there is. let's go ahead and put in a public int flood chance equals 33, which we're not going to really utilize right now. Well, we are, but we're going to comment it out because it's not fully 100% working, and that will be something that we tackle next episode. Okay, so next, let's go down to our clear map, and we'll just do regions.clear. Excellent. And then we'll just, I guess, trust that garbage collection clears this up. But, it's a great idea. But we'll go ahead and right here underneath our map heights where we generate our map heights, we will then say tile. Wonderful. And then here, instead of doing it this way, we're going to make this quite a bit different. So tile now equals get tile, not tile set, tile, and that'll take in map heights as well as I and j. Now get tile, obviously, is not implemented yet. That's okay. Let's go ahead and implement that right now. So let's generate that method, and we will get rid of that. Wonderful. So get tile is, let me find it in my other project here. Where are you, get tile? There you are. Okay, so this is going to be a tile equals tileset.baseTile to start with. And then we'll simply return tile so that it compiles. Excellent. And now we're going to go ahead and get us a map region. Map region equals get region from coordinates. And the coordinates will be ij. Although, realistically, I used xy in the other project, and I'm just going to use xy because that's just a little more convenient than the auto-generated ij for me. So this will be get region from coordinates xy. Now, of course, get region from coordinates doesn't work. There isn't a method for that. So let's generate that method, and let's just get our region from coordinates. So we are going to implement this pretty simply for int I equals 0, I is less than regions.count, I++, if regions I dot contains, which is not the list, this is the method that we created. We're going to pass in xy as our coordinates because I don't feel like making a tuple here. It'll make one for us. We'll just simply return regions I, if that's true. Otherwise, we will return null. Okay, there we go. So that's get region from coordinates. That gets us our regions. Now, regions aren't being generated, but that's fine. We will do that in a little bit here. So let's go ahead and work a little bit more on our get tile. So first thing we're going to need to do is we're going to need to see, let's see if we're underwater here. If region.flooded tile equals tileset.waterTile. Excellent. Now we're going to do two integers here, int numSame equals 0 and int numDiff equals 0. Let's check all the surrounding... Is that 3 R's? That was 3 R's. Okay. Let's check all the surrounding tiles and see if any are a different height. For int I equals... This is just mathf.max x minus 1 and 0. This is what we did last time. I is less than mathf.min x plus 1 and map size x and I++. We'll also iterate on the j, the same 3. Well, the same 0 to 3. For int j equals mathf.max. This will be, of course, y minus 1 and 0. And then we will do j is less than mathf.min of y plus 1 and map size y. J++. Excellent. That was a P, apparently, rather than a curly brace. There we go. So now we'll say if map heights ij is not equal to map heights xy. So if our iterated map height is not the same as our map height that we're checking here, then numDiff++. Else, numSame++. Excellent. So we now know how many tiles around us are different and how many tiles around us are the same. We're missing a closing curly brace for this for loop. There we go. Excellent. So if our number of difference is greater than 0, then we know we're not a flat tile, right? We know we are some sort of other tile. So we should now figure out if we're going straight or if this is a corner. So let's say we should figure out if we're going straight or if this is a corner. So we'll do line direction. If our number of difference is equivalent to our number of the same, then our direction equals line direction dot straight. Easy enough. Then else if numDiff is less than our number of the same, then we know that this is a corner. Direction equals line direction dot corner inside. And again, this is taking this really, really simply. There are two more things that this could potentially be, as in islands and as in peninsulas. We're discounting that for right now. Otherwise, if it's not any of that, then we know that this is direction equals line direction dot corner outside. Excellent. So we're not flat, so this is either a cliff or shore, depending on the flood value. So we'll take if region.flooded. In this case, we will say we're below water level, so this is a shore. So we'll say if our direction is equal to line direction dot straight, tile is then equal to tileset dot shore tiles, and we're going to use that extension that we wrote a little bit ago, dot get random item of type tile, and we'll pass in our random generator. Excellent. Then we can say else if direction equals line direction dot corner inside, then we can say our tile is of course equal to tileset dot shore corner inside tiles dot get random item of type tile random. Excellent. And then we can of course say else this is an outside corner, tile equals tileset dot shore corner outside tiles dot get random item tile random. Excellent. Okay, so there's the shore bits done. Of course, again, this is keeping in mind this doesn't take into account a couple of different things. So we'll do the same thing for cliff. We're not flooded here, so this is a cliff. If direction is of course equal to line direction dot straight, this is going to be basically exactly the same thing. Tile equals tileset dot cliff tiles dot get random item, and this will be of type tile, and we'll pass in our random generator. Else if direction equals line direction dot corner inside, tile equals tileset dot cliff tiles dot get random item of type tile random. Except this shouldn't of course be cliff tiles, this should be cliff corner inside tiles. Otherwise, we're going to say, this should not be evaluating. There we go. Otherwise, we will say tile equals tileset dot cliff corner outside tiles dot get random item of type tile random. Wonderful. So there is our get tile complete, and we can go back up to our generate map here and continue work on this. Wonderful. So let me just get up there in the other project. There we go. Okay, so we're going to be changing this from tileset.baseTile to simply tile. And then we're going to take this out of here. We're going to cut this so that we have it in the clipboard. And then we're just going to simply say get tile position. And this is going to be tile map heights ij. Wonderful. Of course, this method doesn't exist. So let's generate that. Where did it generate that? Right here. Okay, so let's do get tile position real quick, and this is going to be extended later. This is not its final form. So first we're going to do float adjust equals, with a D, adjust equals 0f if tile.tile type equals tile type dot cliff adjust equals negative 0.8f. I just want to do a quick adjustment there if this is a cliff, and again, we're probably going to revamp this method a little later on. But for now, we will simply return that vector 3 that we copied to the clipboard. Wonderful. Okay, so that is fine, although we do want to change this height to add in the adjust. Okay, so there's our get tile position. And generate map is, of course, right here. So this is now nice and short, so we can bring this onto the same line. But we kind of want to generate our rotation as well. We don't want to have this hard-coded rotation. So we're going to get rid of this, and we are going to do get tile rotation. And this is going to pass in tile, map heights. It's going to pass in I and j. Excellent. And we will go ahead and generate that function as well. Wonderful. Now this is one that we're definitely going to be expanding next episode, because our tile rotation is not going to be correct this episode, and we're just did not have enough time to get to it this time. So we're for now going to say int rot y equals 0, and we're going to say if tile... Actually, you know what? Let's just not do any of this. Let's just simply return this quaternion.euler. All of that I had there, I was planning on actually implementing the rotation. It's not happening this episode. So let's just return this and have that be essentially a placeholder. We're going to need an extra closing parenthesis here. Excellent. And then in terms of our... In terms of our actual generate map here, I do believe we are pretty much done. I do want to put in down over here, spawn decorations, which isn't going to exist yet. We're going to generate that. It's just a private void. We're not going to have it do anything right now. Excellent. Okay, so we are still going to need a couple more things. When we are generating our height map, where is our height? Here it is. When we're generating our height map here, we're going to need to, before we smooth the height, generate our map regions. And that'll take in map heights. Just like that. Now, of course, this doesn't exist, so we'll generate that method. And this method is going to be relatively simple. It's going to iterate over map heights and say for int I equals 0, I is less than map size x, I++. For int j equals 0, j is less than map size y, j++. It iterates over the entire map here and says if is coordinate in region and then we'll pass in ij. Then we'll continue. Now, of course, isCoordinate in region doesn't exist. So let's go ahead and generate that method as well. And this is a very, very simple method that we're going to do here. For int I equals 0, I is less than regions.count I++. If regions I dot contains coordinate, which would of course be, this takes in a tuple here, actually. Yeah, this needs to be a tuple. Int. And then this would be, we'll call this coordinate. Coordinate. Then we'll return true. Otherwise, we will return false. Okay, so we'll need to make an overload because this is, of course, using an overload here. Public bool isCoordinate in region, and this will take an int x and int y. We'll simply return isCoordinate in region, new tuple, int of x, y. And that's just to save us a little bit of typing. Okay, so that gets us whether our coordinate has already been sorted into a region or not, and because we're doing this via hash set, this is pretty quick, realistically. Excellent. So, if we are not sorted into a region, then we'll need to create ourselves a region. So map region equals new map region. And then we'll say region.addRange. And we're going to do a flood fill algorithm here. Map heights, I, and j is what we're going to need to pass in. Now, flood fill obviously doesn't exist, but let's just finish out generate map regions first before we implement the flood fill algorithm. And we'll say regions.add, and we'll pass in that region. And we'll also say region.height equals map heights of I, j. Excellent. And we'll also, I'm going to comment this section out, because this section doesn't fully work the way I'd like it to. So we're going to do if random.next, not nest, next, 0, 100 is less than flood chance, then region.flooded equals true, although this should not be a capital F. There we go. And then we will simply uncomment block that. Okay, so this is going to be commented out for now. We're not going to do that. We are going to go ahead and implement our flood fill algorithm, though. This is going to be done relatively simply, in theory. Okay, where am I calling this method? We haven't implemented that one, have we? No, we have not. Okay, I did a lot of new methods for this particular episode. Okay, so we need to implement this flood fill algorithm. This is a pretty basic flood fill. And let me just find the flood fill over here. I need to sort this into regions. Today was supposed to be a maintenance episode, but I just felt like doing this, so that's the thing. We'll probably sort this out in a maintenance episode quite soon. But first we're going to say list tuple of int region equals new list tuple of type int. We're also going to do a hash set here for the simple reason of being able to check if it contains. So that'll also be a tuple of type int, and we'll call that the hash region equals a new hash set of type tuple of type int. Wonderful. We're also going to create a stack of type tuple int, and we'll call that points. And we'll make a new stack there. Excellent. And now we'll do an int target height equals map heights at position ij. I used xy. I'm going to go ahead and rename that here. I feel like that's just a little bit better. There we go. Okay, and then we'll say points.push, new tuple of type int, and that would be xy, while points.count is greater than 0. What did I do wrong on this tuple? Nothing. Okay, while points.count is greater than 0, we will iterate over this, and then we'll just return the region at the end. But we will simply say tuple int points, or rather point, equals points.pop, so we'll pop that off the stack. And then we'll say if map heights at point.item1 and point.item2 is equivalent to the target height and not already considered, so not hash region dot contains point, then we'll say region dot add point. We'll also say hash region dot add point, and we'll need to, no, I keep doing that. We'll need to then push on our points for every direction so that we can consider every potential tile that could be in this zone. As long as it's equivalent to our target height and adjacent to this point, then it's within this region. That's our definition of region here. So if point.item1 is greater than 0, we will then say, I accidentally removed that. There we go. We'll say points.push onto the stack a new tuple of type int, and that is going to be point.item1 minus 1 and point.item2. I keep doing that. I keep searching for semicolon because I'm trying to hit semicolon and control S at the same time. If point.item2, or rather item 1, is less than map size x, I believe this should be minus 1. We can double check that probably next episode. Points.push, new tuple of type int, thank you compiler, point.item1 plus 1, and point.item2. We don't care about diagonals here, we're just going for cardinal directions. Diagonals will be gotten in the next location. So if point.item2 is greater than 0, then we will say points.push, new tuple of type int, and that will be a point.item1 and point.item2 minus 1. And then if point.item2 is less than map size y minus 1, we will then say points.push, and that'll be a new tuple of type int, point.item1 and point.item2 plus 1. Okay, so that's our flood fill algorithm right there. Fantastic. So our map regions will get generated, and we get flood filled there. Excellent. Next, there is something that was calling a method that I created on the other project that we didn't seem to get to here. And I'm wondering, go to, or rather find all references. Okay, that's in get tile. Oh yeah, we should have implemented that. Well, we've got these errors. That's okay. We are expecting a parenthesis, I believe. Or one too many parentheses? One too many parentheses. Fantastic. We've got get tile position. Get region from coordinates. Okay. We don't have any issues right now. So let's fire this up and see if this does what I'm expecting it to do. I feel like I'm forgetting something, but I don't know what. So connect to the server. We should not see any water. We should see a substantial amount of if I can log in here, we should see a substantial amount of incorrectly rotated tiles. Like, this is definitely going to look wrong. Yeah, you can see here, these tiles are definitely incorrectly rotated. We've got some potential height issues, like here, although realistically... yeah, there are potential issues. Mostly, you can see that it's rotational issues. We can address these potential things here, and of course, these are not the same material. That is also something that we can address in the next episode. But you can see that this is, by and large, creating the correct tiles. So if we come, for example, over to this tile here, well, that doesn't look very correct, but if we go into here and we rotate this on the y-axis by 270 degrees, and then this one on the y-axis by 180 degrees, and this one also by 180 degrees, you can see, well, this is actually correct. It's just not rotated yet. Fantastic. So I think we've got a few height issues. Like, I'm pretty sure that these two tiles are not on the correct height. I'm pretty sure they're supposed to be up. If we add 0.8, I'm pretty sure they're supposed to be here. And then we also rotate them to be like that, of course. Yeah, that's how they're supposed to be. So some of these tiles are not exactly where they need to be, and we need to determine when that's going to be the case. But we'll be able to see that much easier after we get our rotations calculated a little bit later on. So I'm reasonably happy with that for now. We are getting good progress. So let's hop over into our to-dos here. Tile choosing is now pretty much done. We can extend that, but the basic framework is there. Next episode is definitely going to be tile rotation, followed by tile water filling and ramps if there's time next episode, or if not, that'll get bumped into the next episode after that. Fantastic! And with that, I'm going to be done for today. You can leave your offerings to the engagement gods in the form of likes, comments, subscribes, and bell ringings, and I will see you all next time.